All the articles you have come to love in EquiManagement Magazine are now available on the EquiManagement on Audio podcast. Each article is released as its own separate episode to make them quick and easy to listen to. Just search EquiManagement on Audio on your favorite podcast player to listen to all the latest articles.
A comparison of cryotherapy techniques to treat laminitis. Laminitis treatment hinges on reducing inflammation in the horse's hooves. Cryotherapy is the gold standard for lowering temperature and inflammation within the hoof capsule to limit laminar separation from the third phalanx. Study results have shown that cryotherapy can be used safely for more than 24 hours to provide pain relief, reduce inflammation, and decrease soft tissue perfusion and metabolic rate. Typically, an effective cryotherapeutic application uses a wet concoction of ice and water slurry that directly contacts the hooves. In contrast, dry therapy uses gel packs or fluid circulation systems that do not directly contact the hooves. Wet therapy can be challenging in some environments. It requires labor and ice, and can make the treatment environment very wet. The ice slurry is applied to the hoof using either 5-liter fluid bags or wader-style ice boots. In many cases, the 5-liter bags have drain holes to prevent oversaturation of the hooves. In a recent study, researchers at Virginia Tech evaluated different techniques for achieving a target hoof temperature of 10 degrees Celsius, 50 degrees Fahrenheit. They compared 3 options: a 5-liter fluid bag without drain holes, a 5-liter fluid bag with drain holes, a commercial wader-style boot. Their objective was to see if the drainage hole bag could achieve faster cooling to lower hoof temperatures than the other options. The study included 4 healthy horses with no clinical signs of lameness or laminitis. Each horse served as its own control. Each received 4 treatments and 4 single-day experimental periods. When wearing the bags or boots, the horses were unrestrained in their stalls. The 5-liter bag had 1.3 centimeter drainage holes, and the top of the bag was taped to the horse's pastern. The researchers emptied the bag and replenished it with ice every 2 hours. They repeated the same technique for the bag without drain holes, so the slurry remained within the bag throughout the treatment period. The wader-style boot was attached with straps to a cuff above the horse's knee, placed over the hoof, and filled with ice. This technique is effective at lowering distal limb temperature and therefore served as a positive control. The contralateral limb without the boot or ice served as the negative control. Every horse had each treatment applied to both front hooves for 12 hours, followed by a 48-hour washout period before the next treatment. The researchers collected temperature readings on the dorsal, medial, and lateral aspects of the hoof wall and lower limbs using a thermal imaging camera rather than using thermocouples within the hoof. Thermal imaging focused on the hoof, just distal to the coronary band, and in the upper quarter. The researchers also recorded ambient temperatures. They monitored vital signs throughout the experiments. All 3 methods resulted in decreased hoof surface temperature compared to the uniced negative control limb. Hoof surface temperature reduced by 2 hours after the initial application. The results are as follows. The undrained bag yielded the greatest decrease in hoof wall temperature. The drained bag treatment limited the extent of cooling, but the lateral measurement did not differ from the positive control, wader boot. The results corroborated findings from a previous study. The boot and ice bag without drainage decreased laminate temperature by more than 23 degrees Celsius within 2 hours. The wader boot was not well tolerated by the horses, and measurements beyond 4 hours of the 12-hour treatments were not available. Hoof surface temperatures reduced below 5 degrees Celsius in both the wader boot and undrained bag applications without adverse effects. The authors believe 10 degrees Celsius is the best target for a treatment protocol. The initial steep decline in hoof temperature in the first 2 hours was followed by a slight gradual rise temperature within 8 to 12 hours for the drained bag and 6 to 10 hours for the undrained bag. This might be due to the tissues attempting to achieve temperature homeostasis via blood flow. The authors concluded that the ice water slurry probably retains better thermal conductivity to more efficiently transfer heat from the hooves to the cooling medium, which it accomplished more effectively in the undrained 5-liter bag or the wader boot. Without drainage, the stall environment remains dry. In summary, cryotherapy with 5-liter fluid bags is best achieved with a non-perforated bag that retains the ice slurry within the bag and indirect contact with the hoof. This offers an economical and practical means of bringing down hoof temperature and metabolism when managing laminitis inflammation and pain,